In this video we're going to take the scene that we've already simulated and rendered in Mantra, and we're going to set it up for rendering in Karma. So Karma is part of Solaris, and Solaris is a USD authoring system essentially. So what we need to do is output our scene, our geometry in the USD format in order that we can then bring it into Solaris for rendering. If you want to learn more about USD, you can look up here on the Pixar website about USD, the Universal Scene Description, and how it works. But I'm going to show you how we can convert our geometry into the USD format in order that we can bring it into Solaris for rendering. So let's have a look at that. So I'm going to go inside my, if you remember, in the house here, we actually created this node for which we rendered in Mantra, and that was the full geometry. If we have a look, we have 500,000 points there, 500,000 points. Now, if I go into the house model here, what I want to do is I want to write this out as a USD file. Now, to do that, USD is best written out using packed primitives because obviously there's a lot less geometry and it'll be a lot much more efficient. So I'm just going to pop a little null in here and stick that out this first branch, which is the geometry here. Now if we middle click, you'll see we've only got 1451 because this is the actual packed geometry. So let's call this packed house, so we know what that is. Let me make that a red color. And what I'm going to want to do is then send this to turn it into a USD and load it into Solaris. So the first thing we need to do is do a little bit of preparation. Let me right click onto the spreadsheet here. Now the way USD works is it refers to the geometry, but it refers to it in a hierarchical form, kind of like a data tree. Well, hierarchy basically. So you have parents and children, you know, folders within folders. The best description is the Windows Explorer. You know, that's a hierarchical system where you've got folders within folders. So we want to organize our geometry. And the way it organizes the geometry, it uses two attributes, a name attribute and a path attribute. Now if we look at packed primitives, they have a name attribute on the points because the packed primitives are points that refer to the geometry, and our packed primitives in the primitive tab here have a path attribute. Now this is no good for USDs. This will make a mess of stuff. The USD actually uses this path to form its hierarchy within Solaris, and we don't want a horrible ugly path like this. What I'd like is a much simpler path, but it's important to have the name at the end. And I also want the name attribute to not be on the points here, but also on the primitives, because that's the other thing in USD. It uses primitives, so we need the primitive attributes. In fact, everything is referred to as a primitive within USD, but it's not the primitives as we know from SOPs. Any object's a primitive in USD, whereas in Houdini we have objects really. But that being said, we need a name attribute on the primitives and a path attribute on the primitives that's a bit simpler than that. So I'm just going to create a wrangle to do that for us. So let's hit tab and type wrangle. And I want a primitive wrangle because I'm adjusting primitive attributes here. But before I do that, I want to just convert the name attribute here into a primitive attribute. And for that, I can use an attribute promote. So let's just pop an attribute promote in there for a minute. Let's tap P. So I want to choose the name attribute, which was the point attribute, and I want to promote it up to a primitive. And look, there we go, we've seen it now appears here. And what I want to do is now reformat this path name. So let me drop the wrangle in here. And the way to do that is very easy. We can type S for string at path. So this will overwrite the existing path attribute, equals, and then we'll put inverted commas to give us a path. So I'm going to put root, which is a /, and then house, and then another /, and then I'm going to close the inverted commas, and then let's put a semicolon in. So you see we've adjusted the path to this, so /house/, but inside Solaris it's going to use this path to organize my geometry. At the moment everything's going to be the same name but within this folder. So what I need to do really is append this with the name of the actual chunk here, so this name attribute. And to do that's quite simple. Here in the path attribute we can append to strings quite easily with a plus, and then we can just put in the new attribute we want to add in there. So that'll be s@name, and which will read in the name attribute for us. And there you can see we've added the name attribute here to the end of the path. So here we have a simple path, house cluster 0 or house glass window, etc. So once we're inside Solaris, we can refer to each individual piece of geometry using this path, which is why it needs to be a bit more sensible. So all our geometry here will be under a folder called house, which will represent the house for us. So this path can be pretty much anything you like, but you want to think of the hierarchy that you're going to create in Solaris. This isn't really a lesson on Solaris so much, but just how to render it in Karma. So if you want to know more about creating those paths, there's plenty of documentation on that at the moment. But so this is pretty much what we want to do for now. We want our clusters and our path set up correctly. So now that I've done that, I can export to USD. So let me do a USD export node. Let's just plug this in at the bottom here. So in my USD export node, there's a couple of settings I just want to change. So on the configure tab here, I'm just going to open up import configuration, and we want to make sure that path and name attribute gets carried through. And the other thing is I want to turn on this authoring here and nested assembly groups and components. This makes sure I get all the nested groups and other bits and pieces that I've done created within the geometry. Let's now also click on the export tab itself, and I'm just going to give this a name. Let's pop that in there, and let's call this SOP USD, so I know I've written it out from SOPs. And we're going to write out one USD file to represent all this geometry, this animated geometry. So let's turn this to render frame range, and then what I'll do is I'll hit save to disk, and then while that's processing, I'll pause the video, and then we'll come back to see how that's done. Okay, that's now processed. And what I want to do now is go to Solaris to bring in that geometry and see if it worked. So, and start to set up the scene. So let's click on the build menu here, and let's choose Solaris, which will set up the interface for working in Solaris here. So there's various things here that we have. We have a here's like a network view where we can edit stuff. Here's a parameter pane where we can adjust things, and here's sort of our like a geometry spreadsheet where we can see the scene that we've created. So the idea in Solaris, we have a stage, and that's basically your scene, and within your stage you populate it with primitives, and primitives are objects. So primitives could be boxes, lights, anything, any scene elements are primitive, even textures are primitives. And you can basically give them hierarchies and override them and do all sorts of clever funky stuff. All we're going to do is simply import some geometry. So I'm going to use a file node for that, and I'm going to bring in the USD that I wrote out. So down here, I'm just going to click on the little browser, just go and bring in our USD file. So there it is. And you'll see it loads up our house into the scene there. And if we drag the slider, you'll see it's calculated all the animation there. And it's rebuilding the scene as we go. That's why you see this kind of a delayed drawing. So this is previewing it in OpenGL at the minute, and you'll see there's no materials and stuff. We have to bring all those into our scene and apply it. And actually look, we can see that when we did that explosion, our constraints on the roof was working quite nice. We've got the structure of the roof. Could have maybe glued the roof to the wall a bit stronger to have it hold on a bit more, but anyway, that's we can recache that a bit later. So you'll see it's quite quick to load the cache in, because we are loading in just point data. That we pack them up before we started. Now if we look down in our stage here, you'll see the hierarchy that we built. Here's root, the /. If we open that up, here's the house, and if we open that up, here's the geometry inside. And if I select the cluster, this is the path that we wrote in our path attribute /house/ and then the name of each individual chunk. And that's how we can refer to these as we begin to set up the scene in Solaris. So what I'd like to do now that we have the house in there, let me just click on the camera here, is add some extra stuff to this. So let's bring in our camera first of all. So it's fairly easy to bring in cameras to Solaris from your scene. If you hit tab and type camera, you'll see there is a scene import cameras. So this is a scene import node. This brings in stuff from Houdini's SOPs scenes rather than from disk. And look, it's set to cameras here, so we're bringing in camera objects. So let me turn this on. And if we click on this drop down, you'll see we have cam 1. That's the camera that we set up in our scene. So if I look through it, that should be how we're viewing from camera 1. So what we can do is add a merge node, and we can merge these two things together, and then you'll see your house hopefully framed how you've set up and how you framed it in the shot. And you can see, if I just close the house hierarchy up, how we now have camera 1 and our house in our sort of scene graph here. There are ways to override the settings and edit them here, but we're not going to do that in this particular tutorial. So the next thing I want to do is add a light. What I'm going to do is, rather than adding bringing in the scene lights, let's create a light directly in here, which we can do. If you hit tab, you'll see there's a bunch of lights in here, so you can bring them from your scene, or you could make your own ones. So let's add a dome light, and again I can just merge these objects together. The merge doesn't really matter. It doesn't work like stops where it matters too much. When you put all these nodes together, and you can do them in one stream, it just fills out the scene here, the stage for you. And look, the stage previews the node that you've selected on it, shows you the construction of the scene to that point. But because this is visible, it's always going to be displaying whatever the output of this merge is. So here's our dome light, which we can edit. So in the dome light, what I want to do is just go to the base properties here, and we'll load in that HDR that we converted before. So we should see that in the path there. So we did that in the earlier videos where we converted this into the ACES color space. And again, we've got ACES here as well. Remember, if you can click on perspective, you can come to correction toolbar, and you can see the usual correction tools at the bottom here. So there it is, lighting our scene. We can check that actually by going to Karma. If you click on perspective here, you'll see we have the OpenGL renderer, and here any sort of Hydra compliant renderers, if you have them installed, will show up. Things like Arnold or Redshift or RenderMan, but I've only got Karma here at the minute, so let's pop Karma on, and then Karma will construct our USD scene for us, and then it will render. So it takes a little time while it makes the USD scene of all these various elements, and then it will render. So I'll just kick in there, and we're not seeing very much. Let me kick back to the house. Now if I go back to Karma, you'll see we're not seeing much of an image. That's because the depth of field of the camera is a bit funky. So what I'm going to do is create a, let's go back to Karma. Let's try and fix that by creating a Karma let's do that again, Karma node. So we can create a Karma node here, and this will create render properties that we can use. In fact, if you click on Karma here, hang on, let me just wait for that to kick in. This actually has the depth of field turned off, so hopefully that will turn off the problem that we were seeing. I just need to wait for that to pop in. There we go. So now our house appears. It's because by default our camera came in with depth of field turned on. If we click on here actually and go to render settings, you'll see without creating Karma render settings, it was using some default ones that we didn't really have control over. But now that we've added this Karma node, you'll see that first of all, actually, if we look down, that's created a new primitive here called render, and there's our render settings, and you'll see that these paths here, look, refer to that render settings. So that's now, if I click on that bottom one, that's now using this Karma node. This other option is also the default renderer is that render setting, so that default option is also using the same node, and now that I've created it, so with the viewport. So sometimes you'll see that when you import a camera, it comes in with the depth of field turned on, and everything's out of focus. So if you just add a Karma render properties, you'll see that that fixes it, because unless you obviously turn back on depth of field here. So let's turn that back off. So if I just step forwards a few frames so we can see the house start to move. Again, we have to wait for Karma to load in the cache there. What we'll see is we already have some motion blur going on. We have some motion blur going on because it's turned on here, and we're actually using geometry time samples here. These are the time samples using the attribute, how the things have moved frame by frame. If you actually want to use your velocity attribute, you can set this to 0 and add velocity, or actually leave that at 2 and set the velocity attribute here. But at the moment it's using the time samples between frames, and because we wrote that out as a USD, it wrote in all those time sample information for us, and we get nice motion blur on our house here. So what I'd like to do now is add some materials to the house. Now that we've got our house in there, our camera and our light. So to do that, we can add a material library node. So this will create a primitive, or primitives for each of our materials there. So let me just select this bottom node. In fact, if I click on this pin icon, there we go. This is not going to change focus now from this bottom node, and I can see everything as we add it. So we've added this material node, but we haven't added any materials here yet. And I've got a few in the scene, and you'd have to fill these out manually, but there's an automatic setup here at the moment, which is pretty cool. If you click on autofill materials, it brings up this little thing, and look, it's going to create a path here. So slash materials. So here we're going to have slash and then a folder called materials, and inside that folder we're going to have the materials that we select. And to select them, you can click on this browser, go to mat, and you can choose the materials that you want. Well, you can't really select them individually. You need to choose the whole context, and it will load all of these in for us. So let's hit accept, and then hit accept again. And then hopefully, there we go, it's filled out all the slots for us there. So this first one's empty. I can get rid of that one. We don't need that one for the minute. And look, there you go, we've got the path to where our shader was. And here it's the name of what it is. This is the name of what it is in the scene here. So if we look here in the materials tab, if I open it up, you'll see it's inherited those names. So that's slash materials, as we saw the path up here, slash materials, and then it's adding this name to each material, ground, whatever. So if I call this, we're not using the principled shader. Let me turn that one off. Let me get rid of that one as well. We will be using the ground. So look, if I put ground 1 in, you'll see it changes the name here to ground 1. So this is how you're referring to it. And this is the path. If we put materials 1, and then we'll have the path materials 1 there. It doesn't matter, as you'll see in a minute, but as long as you know what the paths are. Let's pop that back again. So how do we assign it to stuff? Well, it's all to do with these geometry paths. That's one of the easy ways to do it. So here let's go down to the concrete. So if I open up my house object here, we can see that the concrete objects were all these clusters, wasn't it? That was the cluster that our cluster node made. So there's a couple of things you could do. You can either drag and drop, so that I can drag this cluster here into geometry path. And you see it fills out the path there, slash house slash cluster 0, as you see it here. Now that's only going to texture this one cluster. But if I put a star at the end, then that's going to texture all the clusters. So cluster and then anything afterwards. And look, you'll see all, let me go back to frame. Oh no, you can see it there. So look, we can see all the bricks have gone this grey colour. Let me go back to before it's exploding. So that means they're picking up the texture. So you can be very specific here with these paths, and obviously good naming conventions and good strategies for using this would be better. I mean, in this brute force case, I could just do star, cluster, star, and then anything called cluster would pick up this concrete material. So we can do the same for wood here. If I go through here, do you remember we called our wood stuff? We called it either door or frame. So the frame was everything, and then we had the door. So I could do star, frame, star. So anything called frame now is or with that frame in its name should pick up the wood. And there you can see all the frames here. Let me make this a little smaller. They've all gone brown. And then we also had door, didn't we? So star, door, star. So anything with door in the path will go brown with our wood. Do we have a door in the path? Let me just check. Let's scroll down here in the list. Why did that not pull it in? So there's the glass, roof tiles, window frame. Maybe it was lowercase door. Yeah, it was lowercase door. There we go. So let's get rid of the uppercase, put lowercase in. And now that'll pick up anything with door in the name. So that should pick up our door for us. There we go. So this is why we had good sensible names. So tiles, star, tiles. So I called everything with the tiles prefix to do with the tiles, that including the ridge tiles and all the fractures and stuff. To use tile or tiles, let me make it a singular. So it doesn't matter if I used it plural. So again, I can check. Yeah, look, capital tile, capital T for tile. There we go. We can see all the tiles now are picking up that material. There we go. They've all gone red. And the last thing to do is the glass. So down here, just to make sure I called it, there we go, glass was in the name, lower and uppercase, so that doesn't matter. So we could do glass star, or you could pull in explicit paths and be more explicit about the how you apply the materials. As long as you've got nice paths here to your geometry, it makes this bit rather easy. So there's my glass material in there. So we'll just wait for that to process. See the little gear icon here, there we go, off it goes. And there's our glass material in there. And of course, as we move through the frames, that's going to keep with us. So now we have our house textured and motion blurred in Karma with our scene camera, and we've created our own lighting, our own independent lighting within the scene. Excellent. It is a different renderer, so it will look slightly different to Mantra. Excellent. So the next thing I want to do is pop in a ground plane. So again, we can create geometry in here. You don't have to bring it in as a USD or as bring it in from your scene as we've done with these other elements. You can create geometry raw. So if I just type in grid, we can create a grid object. So there's my grid, and we can give it an initial scale. Let's maybe give it an initial scale of 100. And again, you've got to merge it in to the network so it gets processed down to the evaluated node here. So there we go, let's wait for that to pop in. And we should see a nice ground plane down at the bottom here. So come on, Mr. Gear Icon, there we go. And there's our grid, our ground has popped in there. And again, you'll see it's inherited the name here, grid. So this is the path prefix, and $OS means just use the SOP name here. So if I change it to ground, that's going to reprocess. It's renamed as ground down here in the hierarchy. So just to show you, actually, in the material library here, the order doesn't really matter. In normal SOPs, if I added the ground in here, it wouldn't work. But remember, these are just filling out this spreadsheet, and then it's processing at the end. So actually, I can do that up here. We have the ground already here. So we could just type in star ground star or root ground, and if I choose that, hopefully now it will apply that material to our ground, and it will go that sort of brown color that we had before. But it kind of makes a bit more Houdini sense to pop this material library down the bottom there, or do it in each branch so that you know that you've applied it. But I just wanted to show that you could, oh, maybe it's not working across there, maybe you do have to have it downstream. Let me just pop that in down there. Make sure it's connected. Yep, there we go. Are we getting an error there? Let me just stop Karma for a sec. Why am I getting an error down there? Let me just disable the node, re-enable it. There you go, error's gone away. And then let's turn on Karma again. So it's just showing me the last image that it rendered. So that's not accurate. We'd have to wait for the little gear icon to change to a pencil. And when that does that, we will see what we need. Oh, crash. Okay. So now if I turn Karma back on, with this down the bottom here, it's able to load the USD in, and there we go. We can see that we're now getting our brown ground there. So let me just stop Karma, and if I pop this guy up on this branch, we go back to Karma, just wait for the gear icon to disappear, and then we'll see our little pencil, which means it's redrawing. And then we'll know how the render will look. There we go. And see it doesn't work. So yeah, it doesn't need to be downstream. So let me just that's what caused it to crash, was unconnecting this while Karma was running. So let me just pop that downstream, and we can play all the shaders at the end there, and then we can see that that's working through. And we could have applied them on each individual branch as well, as you know. So we have our scene in there, we have our ground plane, we've got our materials applied to everything. What we want to do now is bring in our pyro. So again, let me stop this, I'm going to go back to my build desktop, and I'm going to write out the pyro simulation now. So I'll just wait for that to display. So if you remember, we wrote that out from the pyro node. We exported that. So it's not pack primitives or anything like that, so I don't need to do anything funky. So let's go back here to the pyro node. There it is. So there's my pyro bake volume. So again, USDs can handle volume, so I want to write out this volume. So again, USD export. So this will write out all of our volumes. So this can get quite potentially quite heavy. So I'm just going to go to the export tab here, and we're going to set this to render frame range. And then let's just give this a name. Let's call this SOP Pyro. SOP Pyro. And then what we'll do is just copy that name, Control C, so I can read that in afterwards. And then I'm going to write this out, and that'll take a little while. So I'm going to pause the video while that writes out to disk. Okay, that's now written out. So I'm going to go back to Solaris. So let's click back on Solaris here. Oh, hello, I've gone to object there. Let me go back into the stage. There we go. Back in Solaris here. So let me just pop the ground up here before the file. Takes a little second for everything to update. So I'm going to use another file node to bring in that USD. So let's pop this one in at the end here. Okay, let's just bring that up. Doesn't really matter too much. We'll make it look neater. There we go. Oh, hang on a sec. Let me go back. There's something important I forgot to mention. Let me go back to here. So on this USD export, we need to call this pyro, actually, because it's going to use this name here to format that path for us, by the way. So you need to rename this USD to pyro, so it writes it out with the correct path for you. So again, I'm now going to pause the video while I write that out again. So now that we're back inside Solaris, back in that file node, I'm going to load in that new cache that I wrote out. So let me just paste in the path here. And if we have a look at this node, we'll just select that node. There we go. So look, it's coming with that name. If you didn't rename it, this would come in as USD export, which is fine. It just doesn't make much sense within this hierarchy. But if you rename that USD export, it will come in with the name here. And if we open it up, you can see there's our volume. That represents our smoke for us. So if I run forwards, give it a second, you'll see it loads it in. Now again, if we come to render this, so again, if I select this last node, we'll see the full hierarchy here. So that we've got our house, our pyro, our render settings, our camera, our ground plane, our lights, and our material. Let me lock this again so that doesn't change focus. Now if we set this to Karma, you'll see there's a slight issue here. Being that the shader is not applied, even though it showed up in the viewport there, because that was the visualizers. When we run Karma again, it doesn't know to apply the material for us, so it just comes out as this dark color. Let me set that back again. So again, we have to build in our material there. So on the material library here, what we can do is add another slot for it. So since it's down the bottom here, so let's click plus here. And then that will create a new slot in this window for us here down at the bottom. And then material VOP, let's click on the browser. If we open up our object, our pyro, here's our bake volume. If you remember, the shader was inside the bake volume, inside the mat net. There it is. So there's the pyro shader that we use for Mantra. So let me link to that. So that knows where the material VOP is here. And we want to give it a material path down here. So we'll just call it pyro shader. So if we look now down in the materials tab here, you'll see it's called pyro shader. And then the geometry path, well, the geometry path actually is our pyro, this volume 0. So I'm just going to drag volume 0 up here into the geometry path. Okay, so that's the name that you want it to be called in the and that's going to be inside this folder, and then you're linking to the actual data there, and this is the path of which you're applying it to. So it'll look the same in the OpenGL, but this time if I render in Karma, that's how it did look. So now hopefully it's going to read in the information from the Pyro shader there and use that in the USD that we construct, and then we'll see our full glorious shading going on there. There we go, that's kicking in nicely. We have our nice shading going in there. So let me jump forwards to maybe frame 44. Remember, that's quite a heavier frame to load up with a lot more disk cache. Again, it takes a while to render here. So what we're going to do in a sec when that's loaded in is I'm going to change some of the render settings here so we get a nice quick render out of it, and then we'll render it up and then we'll have a look at it side by side with the Karma one. So there you go, that's sorry, with the Mantra render. So there we go, that's a much later frame, and that's fairly quick to get started. So let me just stop this. So let's talk about some of these settings quickly. So let's just call this Karma, so we can write that out. In fact, let's call it, let me undo that, let's do hip name, and then dot Karma test, something like that. And then I want to change the side here. Now first of all, this camera is not linked to the right camera, so what we can do is just click the drop down here and choose our camera, camera 1. Just like Mantra, that's a default path and we didn't have the default camera, so make sure you choose the right camera in your drop down here. The resolution, let's do this 852 by 480 because I haven't got great resources, so 3/4 res. And then what I'm going to do is come down here to pixel samples. This is important. So the pixel samples here, this is a quite high quality. It takes a very long time to resolve. I'm going to set this to 8, which gives quite good results, as you'll see. Especially gives great results if we well, let's go to the limit tab and just yeah, let's leave the limits as they are. It gives particularly great results when you go to image output here and go to filters, because often you can turn on the optics denoiser. So you can get away with much lower sampling settings if you use the denoiser. So this will give me quite a reasonable render at the settings that I've got. Now if you don't have that option or it's not installed, you can simply go to the edit menu here. Is it the edit menu? Go to, sorry, the render menu and choose download optics denoiser here, and you'll have to restart Houdini once you've done that, and then you'll be able to use it in the options over here. The other thing I want to do is just make sure that we're using the ACES color space, because remember we've rendered it in that. So here is the open CIO, the open color. So we can open up this for the ACES color space. So remember we're working in ACES CG. So I'm going to output this as ACES CG as an EXR file, so when I bring it into my comp or other programs I know it's in the ACES CG format. If I was writing it out as something else, I might change this to sRGB or something like that, but I'm going to keep it in the ACES CG for now, so we'll pop that to ACES CG because that's what we've been seeing it through for the whole time. And that's pretty much it for those settings there. I'm just going to come up to the top here and set the frame range, and then we'll save the scene, and then I'm going to hit render to disk, and I'll just pause the video while I do that, and then we'll look at the two renders once they're completed. So that's finally rendered. Here's the render from Karma. So we'll see we've got our nice motion blur, and we've got a different lighting obviously to the Mantra one because we set up a different dome light with a different position and stuff. But there we go, we've got the nice render there with the optics denoiser, which does soften out some of the detail ever so slightly. And here's our Mantra one on the right hand side. So we can see them almost going together there. And the looks are very, very comparable. Obviously the optics denoiser's losing a tiny bit of the crunchiness there. But they're all rendered from the same sim. So there you have it. You can see that it's quite easy in SOPs to set up some very complicated rigid body simulations and then control them with Pyro. It's very lovely now with those new Pyro shaders to in Houdini 18.5 to get some really nice detailed looks out of it. And then we've looked at how we can render all of that stuff in Mantra and then convert everything into USD formats so we can then load it all into Solaris and render it through Karma. So hopefully everybody has enjoyed that, and we'll see you soon. Thank you very much.